Hello everyone. In this video we're going to talk about the attributes of polynomials, domain and range. So we've spoken about domain and range before, so hopefully this is a bit of a refresher, but now we're going to talk about specifically for polynomials. Alright, let's get started. As I said before, or just now, we've spoken about domain and range, so if you want to go to my other video and watch more in detail about domain and range, you definitely can. Here I'm going to give you an overview of what domain and range looks like for a polynomial. Now, domain, if recall, we're talking about the set of x values, right? So we're looking at where does this function intersect the x-axis, or necessarily where does this function exist on the x-axis. So we're looking at the set of x values. So what I like to do when I'm looking at the x values is I actually like to draw my lines. Where does this function look like on the end of the x-axis and on the right on the x-axis? Where does it exist between those two? Okay, whatever that number is what my interval is going to be. So let's say that this number is, I don't know, -5 and +7. The domain is going to go from -5 to +7, and then you have some sort of function in between them, right? Maybe you have a picture that looks like this. Right? And the domain goes from -5 to +7. That is what you're looking for the domain. The range is a set of y values. I'm going to change colors for this one. This one's looking at the y-axis. So I'm going to draw my line horizontal on the y-axis. What set of values is it going to exist between here in the red? Okay, so let me just color code this so you can see that we're dealing with the y values. So maybe down here, the lowest number down here is -3, and up here we have +4, right? So here my range is going to go from -3 to +4. You're looking for where does this function exist? So I draw these horizontal lines and these vertical lines to show me what it looks like, right? So if I'm looking at the domain, I'm looking at where does it cross the x-axis. I'll do that with the highlighter. This x-axis from here to here, where is it going to exist? This is the domain. You're looking at a vertical line on the x-axis. The range is going to be a horizontal line on the y-axis. Where is it going to exist on the y-axis? From where to where? And that's how you categorize it. Now you might be able to do this on interval notation or inequality notation. Okay, I'll show you how to do both here as we start doing some examples. So let's dig right in. But my method, as I'm saying, is I draw these vertical lines to see the boundaries of what it's going to look like. In this example, I have a even exponent polynomial because both arrows are pointing in the same direction. And I'm going to start with the domain. I'm going to start with the domain, and I'm going to do this in blue. I'm going to look at the domain, the x-axis, here and here. Now, for all polynomials, okay, because you're going to always have two arrows on both extremes, on both endpoints, the domain is always going to go from -infinity to +infinity. You're always going to have two sets of arrows for polynomials, right? A quadratic, as you can see in this picture, the arrow is touching my boundaries, which means that this boundary doesn't really have one. It's going to keep going to -infinity and +infinity. And you can write it in interval notation, or you can say that x exists between +infinity and -infinity. This is the inequality notation. They're both going to be the same representation, basically. Now let's look at the y values, the range. The range will have its limitations, right? Here at the bottom, I start at -4, and at the top there is no boundary, because if you look at the top, there are arrows touching that boundary, which means at the top it'll go to +infinity, right? But down here it starts at -4. That's going to be the lowest value. So for the range, we're looking at the y-axis from -4 to +infinity. -4 has a bracket because it includes it. That point exists, right? It exists down here. And then at the top, it does not include the infinity because the arrows keep going towards the positive infinity. You can write it like this, or you can say y exists between infinity and -4, where it includes the -4. And this is pretty much it, guys. I draw my vertical lines and my horizontal lines, and I assess what I'm looking at. Let's try another one. So for domain, let's clarify this again. All right, remember, domain will always include, all right, notice how there's arrows touching the domain, which means it's going to keep going towards negative infinity and positive infinity. That's why domain will always be negative infinity, positive infinity for both, because the arrows will do that every single time. It doesn't really matter what polynomial you're dealing with. It'll always be from negative infinity to positive infinity. The range is the one that matters, the one that changes. So if we look at the range, look at down here and look up here. Look at these two boundaries. Notice how these two boundaries aren't really boundaries because down here at the bottom, I have an arrow and an arrow, which means they will go from negative infinity to positive infinity as well. There's no limitations for these in this picture. You can see y is between positive infinity and negative infinity. Oops. For this case. Now notice how this one is an odd function because it has arrows pointing in opposite directions. I have an arrow pointing down here and an arrow pointing up here. From our previous video, we spoke about how odd functions have arrows pointing in opposite directions. So if you have an odd exponent function, you're always going to have an arrow pointing down and an arrow pointing up, which means there will be no boundaries either on the domain or on the range. So this function, odd exponent functions like x to the third, x to the fifth, x to the seventh, all of those will always go negative infinity to positive infinity. Let's try one last one. Why don't you give this one a try? Label the domain and range, give it a pause, come back and see if we got the same solution. Notice how there's no boundaries on domain because the arrows are touching both of those lines. Again, another representation of why we're going from negative infinity to positive infinity every single time. The range. What is the range here though? The range has a limitation. Notice how there is a global maximum. Now, down here, down here, we don't have a limitation because the arrows keep going downward. But up here, there is a limitation at 1, 2, 3, 4, 5. So the function is going to go from negative infinity down here all the way up to 5. Anytime you have a global maximum, like you here, or maybe a global minimum, the range is going to be affected. So we can say that the function goes from negative infinity to 5, or y exists between those two values. Okay, so let's recap a little bit. Okay, let's put all of this sort of together. Let's call this a review. So, to review this whole thing that we spoke about, the domain of any polynomial will always be from negative infinity to positive infinity. So let's put this in blue. Domain. Always from negative infinity to positive infinity. Because the graph, as I pointed out earlier, whatever the picture is, right, the graph will have no boundaries. There's an arrow here and an arrow here, which means the arrow goes from negative infinity to positive. There's no boundaries left and right, ever, for any polynomial. The range, that's where things change. okay? The range will go depending on the function. So you have two possibilities for the range, okay? We could have an even function, an even exponent function, looks like something like this. Or we can have an odd exponent function that looks something like this. For range, you could have a global minimum that goes from here, if you notice, from a number, whatever number that is, to positive infinity. Or maybe you have, like in this other scenario, the range down here to up here. Notice how down here we go from negative infinity to positive infinity because there's arrows on both sides. So if it's an even exponent function, it will have either a global maximum or a global minimum where it will have a boundary, but then the other side will always be infinity or negative infinity. When it's an odd exponent, like this one, because the arrows are pointing in the opposite direction, then you're going from negative infinity to positive infinity as well. So it really depends. Does the function, the question that I'm going to ask myself is there a global maximum or minimum? If there is, then your range is going to be affected by that. If there isn't, then it'll go from negative infinity to positive infinity. If you're not quite understanding global maximum, global minimum, what I'm referring to, watch my other video titled Global Maximums and Minimums to better understand the situation. I hope this helps. Please let me know if you have any questions. And as always, I'll calculate later.